What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A Plus 1201 certification exams. So let's get into it. All right, so RAM, which stands for Random Access Memory. This sounds way more complicated than it needs to be when you first hear about it, because people throw around terms like DIMM, DDR5, ECC, and dual channel like they're supposed to know what all that means right out of the gate. But don't worry, if you're preparing for the CompTIA A Plus 1201 exam, this video is going to walk you through everything that you need to know. By the time we're done, you won't just understand RAM, you'll probably be able to explain it like a pro. So with that being said, let's go. All right, so exactly what is RAM? Well, RAM, once again, this stands for Random Access Memory, and it's basically your system's short-term memory. So think of it like your brain's ability to remember what you're doing right now. When you open up a browser tab, you load a game, or you work in Microsoft Word, your computer loads these things into RAM so they can run fast and smoothly. And once you shut your computer down, the data is gone because RAM is volatile memory. And hard drives and SSDs, these are like your long-term memory. They're slower, but they keep things around permanently. RAM, on the other hand, this is all about speed and temporary storage while the system is on. All right, so now that we got that understood, let's start with how RAM looks physically, which is also known as its form factor. And there are two big ones that you need to know about for the exam. The first is called DIMM, and that stands for Dual Inline Memory Module. And basically, this is the standard type of RAM that is used in desktop computers. It's typically around 5.25 inches in length. It has 240 pins for DDR3 RAM and 288 pins for DDR4 and DDR5. And you can find this being used in desktop PCs, workstations, and servers. And then we have what is called SODIMM, or Small Outline DIMM. And this is a smaller version of DIMM that you will find in laptops and small form factor PCs. And it's typically around 2.66 inches long. It usually has 204 pins for DDR3 and 260 pins for DDR4 and DDR5. Once again, you'll find this in laptops, compact desktops, and mini PCs. So remember, SODIMM, these are built for tight spaces when your device doesn't have the room for a full-size DIMM. And as an exam tip, if the exam asks you which form factor is used in laptops, the answer is always going to be SODIMM. All right, so let's talk about the brains behind RAM, and that is called DDR technology. And DDR, this stands for double data rate, and it basically means the RAM can send 2 data bits per clock cycle instead of 1. And this has been a huge performance booster over the years. And here's some of the key things that you need to know. When it comes to DDR, they are not interchangeable, meaning you cannot stick your DDR4 into a DDR3 slot and expect it to work. Each generation is faster and more power efficient than the last. DDR5, this is the newest mainstream version and is being adopted into newer systems. And then there's the issue of DDR naming confusion. So you may see RAM labeled like DDR4-3200, and that basically means it runs at 3200 MTS, or you might see PC4 25600, which is just 3200 MTS times 8. And here's a quick comparison table going over the various types of DDRs from DDR1, 2, 3, 4, and 5. And to help you remember all of this stuff, just think of it like this. DDR1, that is old school. DDR2 is a slight upgrade from DDR1. DDR3, this is still hanging around. DDR4 RAM, that is still being used today. And DDR5, that is the future of RAM. All right, next let's talk about this thing called ECC RAM and non-ECC RAM. So this is where things get interesting and a little bit nerdy. So what is ECC RAM? Well, ECC, this stands for Error Correcting Code. And this is a type of RAM that detects and corrects errors that can occur when bits get flipped due to electrical interference, radiation, or just plain randomness. And this is used in servers, workstations, financial systems, medical equipment, or any place where data integrity is critical. And when it comes to ECC RAM, this has an extra memory chip on each stick that handles error detection and correction. However, ECC RAM can be slightly slower due to the error checking process, and it can also be more expensive because of the extra reliability. And then we have what is called non-ECC RAM, and this is the standard memory that is found in most desktops and laptops. It's faster and cheaper, but it does not check for errors. However, it is perfectly fine for gaming, browsing, office work, and casual computing. So when it comes to both of these types of RAMs, well, how do you tell them apart? Well, ECC RAM, this usually has 9 chips. You have 8 for data and 1 for the error correcting code, while non-error correcting code has only 8 chips. Also, ECC RAM often says ECC are registered on the label. And when it comes to ECC RAM, it usually will not work on motherboards that do not support it. Now, as an exam tip, if you're working with mission critical systems, then ECC is a must. Otherwise, you're going to stick with non-ECC. All right, so let's move on and talk about channel configurations. So RAM does not always work solo. It can be part of a team, and how that team is set up affects performance. And that's where channel configurations come in. So the first channel configuration is called single channel, and that is when you're using only one stick of RAM on its own, and this offers the lowest performance, and this is not ideal for multitasking or gaming. You have what's called dual channel, and this is when you're using 2 sticks of RAM to work together in tandem, and each stick handles half the data bus width, which doubles the memory bandwidth, and this is common in most modern PCs, and this offers great performance for general users and gamers. Then there's triple channel, and this was introduced with some older Intel motherboards. And this is where you're using 3 memory sticks that are working together, and this is not widely used today, but you may see it in older server setups. And then you have what is called quad channel, and this is found in high-end desktop systems and servers. And this is where you're using 4 sticks of RAM that work simultaneously, where it offers very high memory bandwidth, and this is great for video editing, 3D rendering, and scientific computing. Now, as an important note, when it comes to channel setup, to activate multi-channel mode, you're going to need the right number of sticks, meaning you're going to need 2 for dual and 4 for quad. Also, the sticks, they have to be identical in size and speed, and the sticks have to be placed in the correct slots on the motherboard. So you want to check the color coding or just simply read your manual. Now, as an additional tip, when it comes to mixing different RAM type sizes like 4 gigs plus 8 gigs, that can disable dual channel. So you always want to match your RAM for the best results. Now, while the A Plus focuses mainly on the points that we just talked about, you may also run into these terms right here. When it comes to RAM, you got what is called CAS or CAS latency, and this refers to how many clock cycles it takes for the RAM to deliver requested data. And the lower the number, then the faster it is. So for example, CL16 is better than CL19, assuming the same DDR type. You also have registered or buffered RAM, and this is often used with error correcting code memory, and this adds extra stability by buffering data, and this is used in servers, not in desktops. And then you have what's called XMP or extreme memory profile, and this basically allows RAM to run at faster speeds than the default, and this is common in gaming systems, and you can turn this on in the BIOS. All right, so now that we discussed all of that, let's say that you're working as an IT support specialist and a customer brings in their sluggish computer. You open up the case and you see that there's only one 4 gigabit stick of DDR RAM, and then it has some additional empty DIMM slots. So here's how you might apply what you know. So when it comes to form factor, you're dealing with a desktop computer, so you're going to be using dual inline memory modules and not SODIMM. When it comes to the generation, we're dealing with a DDR3 stick. Now that is older, so you may want to upgrade to the DDR4 if the board allows it. When it comes to channel configuration, as you can see, they said they only have 1 stick of RAM up in there, so we're dealing with single stick or single channel mode. So you could add another 4 gigabit stick of the same speed and brand, which will enable dual channel. And then when it comes to upgrade plans, you might want to recommend upgrading to 2 8 gigabit sticks of DDR4 if possible to get better performance, especially when it comes to things like multitasking or gaming. All right, so let's bring all of this wonderful knowledge together. So when it comes to RAM form factors, you got 2 types. You got DIMM or dual inline memory module, and that is used for desktop computers. And you got SODIMM or small outline dual inline memory modules, and those are used for laptops. When it comes to DDR iterations, it goes DDR, then DDR2, then 3, then 4, then 5. And basically each one is faster, uses less power, and is not backwards compatible with the previous version. You also have error correcting code versus non-error correcting code. So ECC, this detects and fixes errors, and you can find it being used in servers. When it comes to non-error correcting code, this is basically regular consumer RAM that you'll find in your computer right now. And then you have channel configuration. options. So a single channel is one stick of RAM, which offers the slowest performance. You got dual channels, that is two sticks of RAM that match and that offers better performance than single. And then you got triple and quad, and these are rare in desktops, but they're more common in high performance or server setups. Now, understanding RAM, this isn't just about passing your CompTIA A+ exam, although that's definitely part of it. This is about becoming the kind of IT professional who knows how to optimize system performance, troubleshoot memory issues, and recommend smart upgrades. So whether you're helping a customer, building your own gaming rig, or prepping a business workstation, knowing how RAM works makes you more valuable. And here's the truth. RAM, this is one of the easiest upgrades to make that gives an instant speed boost. So if you understand how to match form factors, channel configurations, and DDR types, then you are ahead of the game. With that being said, let's do some check on learning. So our first question is, which of the following memory types is most commonly used in laptops? Would this be SODIMM, ECC RAM, DIMM, or registered RAM? And the correct answer is SODIMM. So SODIMM, once again, this stands for Small Outline Dual Inline Memory Module. And this is the compact form factor of RAM that is designed for laptops and small form factor devices. DIMM, this is used in desktops. And error correcting code RAM and registered RAM, these are typically found in servers. Next question. What is the primary difference between ECC RAM and non-ECC RAM? Is it ECC RAM uses less power than non-ECC RAM? Is it ECC RAM is used only in gaming PCs? Is it ECC RAM can detect and correct memory errors? Or is it ECC RAM is required for all desktop motherboards? And the correct answer is ECC RAM can detect and correct memory errors. So error correcting code RAM, this includes an extra chip that detects and corrects common data corruption errors. And it is used in servers and mission critical systems. It is not typically used in desktop or gaming PCs. And our final question is, which of the following setups will most likely enable dual channel memory? Is it one 16 gigabyte DDR stick, two 8 gigabyte DDR4 sticks installed in separate channel slots, two RAM sticks with different sizes and speeds, or three sticks of 4 gigabyte DDR3 RAM? And the correct answer is two 8 gigabyte DDR4 sticks that are installed in separate channel slots. So dual channel memory, this requires two identical or very closely matched RAM sticks where they are the same size, type, and speed installed in the correct slots. And this allows them to operate in tandem and boost memory bandwidth. Option A, this runs in single channel. Option C, this will disable dual channel. And option D, this is a triple channel configuration, which is not typically supported in standard consumer boards.